I did a whole 1 hour lecture one time, didn't have that recording turned on. It was really bad. I was not happy. Had to redo it. But I do have everything on there, and I think that's going to be very helpful to y'all. In case, because sometimes I'm getting old, I may hit better if somebody may ask a question. But I would definitely watch over that chapter 1 because I know I went through it a little bit slower than we did yesterday. And I think we're going to have plenty of time, so I shouldn't be rushed. But I believe in getting ahead and staying ahead. Okay, now, real quick. So my gentleman got me a good point here. I moved all the chapters, 2 and 3 is due tonight, right? Tomorrow about 10:30, right? And I thought that I just said it right before last time, so you could get up in the morning and do it. And I think it might be a huge deal for y'all if y'all did look over, like chapter 3 before we try to do chapter 3 tomorrow. Now I don't think I can do all chapter 3 tomorrow. I think I have 2 days on the outline to do that. Speaking of which, let me get my lady that was not got here, lady. Was being nice and not coming to interrupt. And I really appreciate that too. Here is the outline here. I'll give you one look at this. And so, yeah, so I kind of, the three is a very long chapter. It has like it's basically 3 chapters in major volume. They put together, the cell protein synthesis and cell cycle. Okay. And we're going to do the cell cycle in lab today, which would be a great introduction to that. So it should go fairly smooth when we get to that in a Thursday or Friday lecture. Okay. I think it's right, isn't it right? Today we're doing cell today. And start tissues, I think, on Thursday. The evil tissue, the most evil one, the first, right? Then you'll go home and contemplate life all weekend and come back Tuesday, it'll be better. It'll be better, I promise. Okay, so don't everybody quit Friday or Monday over Thursday's lab. Thursday lab has the potential to really scare people, okay? Okay, so everybody got that. So make sure that you've got your access working on mastering right. Oh man, look, my online class, the darn code ain't in the book. It's a meltdown. We're having a meltdown. I got people freaking out. So I came in this morning and called them and told them just to use the free access. So y'all don't use the free access because then you have to go back in there with the real code and it can get weird if you let it expire. We've had people, that you tell them every word is free code and then they go ahead and do what? The free access, right? Or put their credit card in. I've had to call and get people money back. They'll go ahead and buy it. So let me know. Don't get burned, but just let me know. All right, so everybody cool with that? Now the rules, y'all read those. I don't have time. You got all that stuff. I think I went over rules. Y'all know you can look at the assignments and see how grades break down, right? And I tell you right now, what's my biggest concern this summer is the fact that we're not going to have a big test of those midterms, right? So you cannot not do anything and wait till the end. You're going to be in trouble, okay? Because the online is very thorough over the first 7 chapters. Okay, am I clear? Okay, I'm just trying to be clear. And then we got some short answer questions today, I think, right? Out of this one, I'll run those off and print them. I just hadn't got to it today because I've lost both of my chemistry teachers have left. They're both of them are ladies that husbands moved. They moved with their husbands to new jobs. So I'm happy for them. But I had a bunch of chemical waste that I need to get rid of before they left because they don't want to know what it is. So I was over doing that this morning. And then I'm about to hire 1 chemistry teacher. I'm still looking to hire another 1 or 2 people, at least another biology person. Okay, so let's do chemistry. Everybody cool? So I'm going to focus here. Let me get this second here and get going. Okay, so this is a fun chapter. It is kind of scary. Now, I know I talked to Bailey and some of y'all got to know a few of y'all yesterday. I really felt good about this class, y'all. I'm really excited about y'all. I think several of y'all probably have a really good background and went to really good. She went to super high school. I know she's not. I'm not going to say anything today that scares you if you had a really good high school. But if you were in a poor high school or then you get then chapter 2 can scare a lot of people because we're going to spend the day talking about chemistry. Okay. And what you got to understand is that chemistry is really the language of biology, right? Everything, our biology is study of life, but chemistry is the rules we must obey, right? So the rules of physics and chemistry have to abide. And I always said this, I love biology because if I brought their dog, or if you don't have a dog, you can probably get a dog for the day and bring it up here. If I came around and kicked everybody's dog in the mouth, what would happen? Well, my winter dog would cry. Bailey's dog would bite my leg off, right? She might have got a wild or something crazy, right? In other words, and then I used to have a dog who would go show you where I have money at the house. She's just like, whatever, okay. And she just licked my hand, whatever. And I would not do that. What I'm pointing is that every living thing responds differently. Biology is unpredictable, right? We don't know how we're going to respond. I say a joke, she laughs, she thinks it's stupid, right? We all behave differently. But chemistry is for OCD people, right? Gas, match, always explosion. Chemical A and B always make C. So it always works. And that's why I like biology, because we can order these cats and they'll be great sometimes, they'll be dissect, sometimes they're rotten and I have to throw away. So biology is unpredictable, right? It has that element of we just not know what's going to happen, okay? All right, so this is a pretty profound one, I think. So in chemistry, everything is made out of what? These atoms, and well, let's define the atoms and elements, okay? This always messed me up. So, and of course, they give it this the next slide, okay? So let's start with the slide here. So matter is everything in the universe, everything that takes up space and has a mass, okay? And there are 3 states that these can be in, right? You can either be a solid, a liquid, or a gas. Until we have the UFO aliens in some new state, we're going to go with that. There is no other state, okay? And in chemistry, then, is the study of matter and how it interacts with each other. Now, in the back of your book, there's a periodic table, and I have one up here, a mini one here in just a second. These are the 92 elements that naturally occur in nature, okay? Now, there are 92 different tinker toys. Now, I did that last year, and the girl didn't know what a tinker toy is, okay? So if we take a break, and I'll try to take a 5-minute break in here. I don't really want to talk for 2 hours, okay? I did yesterday. But I will get the tinker toys. Everybody know what tinker toys are? Oh my God, no wonder y'all are so I'm worried about this. Some of y'all. Now I got a lot of faith in y'all generation. Okay. Okay, y'all know what Legos are? Yeah. Okay, there are 92 different Legos in the universe. Okay, I'll show you tinker toys in break. Okay, that's what I had as a kid. These little sticks. You probably seen the little yellow sticks and green sticks, and they got the little round thing with holes in it, put sticks in, you can build stuff. Like Lincoln Logs. Remember Lincoln Logs? It's kind of like Lincoln Logs. But Lego, because Lego movies, y'all know what that is. So just imagine there are 92 different Legos in the entire universe. And everything is made out of putting those together. So in nature, there are 92 elements, okay? 92 different elements. And an atom is the least amount of one of these you can have and still have that particular element or atom. Okay, so there are 9. So if I had a bar of silver, it would be made out of millions of atoms of silver, right? But I can cut it down to I have 1 atom of silver. If I cut it again with a laser, then you don't have silver anymore, you have another element. So the elements can change form because what are elements made out of? Protons, neutrons, and electrons, right? So just real quick, there are 92 different elements. Now somebody right now is going, Robin, I've been enjoying your class, but you're confusing me because I remember in chemistry there was a 93, 94, 95, and there's up to like 108 now. Well, everything above 92 is man or woman made by human science. I say mankind, but that's kind of sexist. I'm a father of 2 daughters, right? So, humans have made everything above 92 in a laboratory, okay? And thank God, plutonium is not out in cold water bottom, right? Plutonium has to be made, and that's what the nuclear weapons are made out of, okay? So everything above 92 is made in a laboratory, and many of them only live for a few milliseconds or whatever. But plutonium is pretty stable somewhat, right? And we can use nuclear weapons for that. Now, for us, and I'm jumping around a little bit, we're mainly made out of the top of the periodic table. And how this actually works, I'll come back to this, but and explain it to you. But each row is a shell of electrons. Okay, we'll see that in a second. But let's don't get ahead of ourselves. But there are 92 of these atoms. Okay, I'm backing up. And an atom is the smallest unit of matter that remains the original property. So you can have 1 atom of gold, 1 atom of silver, 1 atom of carbon, 1 atom of nitrogen, or whatever. Now, the subatomic particles themselves, atoms are made out of 3 subatomic particles. Okay, we've known this for almost 200 years, probably. So atoms are made out of protons, neutrons, and electrons. Okay, and they have the same configuration. In other words, you have a nucleus in the middle that contains the protons and the neutrons, and electrons are found circling the nucleus in what we call shells or orbitals. Okay, now here's one of my big connectors that really helps me out. This made me feel better a long time ago. God made the subatomic universe, meaning all of everything in the universe is made out of these atoms that look like the darn solar system. Bam. We know that the solar system is made out of what? Stars with planets circling them, all the Earth circling the sun. And only about, 20 years ago did we prove there are other planets in the universe other than the 9 or 10 in our little solar system, and we still argue about Pluto. Is it a planet or is it an asteroid, whatever. And my favorite one, what's the other one that everybody makes fun of? Uranus? So this is the one that it's another one that we're not sure. People argue about that one. Okay. But anyway, but right now you talk to the astronomy people, they say there's 9, there's 8. I don't care. But we know now our physicists have proven that there are other stars, and the way they move, we know that they have planets around them because of the gravitational movement of those stars. So there are probably millions of planets out there, and we've already found a couple hundred that are far enough away from their star to sustain life like it is on Earth. And I believe there's other people out there, other living things out there, and I think it would be a biggest waste of space ever in the universe to not have life on other planets, right? Okay, and I think it's cool, and I think God did it, but it's just we got to quit thinking that we're the only ones out there. I think that's a little naive, you know. Okay, I think it's a little naive. Okay, now whether they visit enough, that's another class. We'll talk about that some other time. Now here is actually a really famous. Okay, this is one I want you to get this to. I think this is a short answer question out of chapter 3. But life on Earth is based on this atom. So carbon is kind of big. Carbon has 6 protons in the nucleus, 6 neutrons, and 6 electrons. And life on Earth is based on carbon. And so if I get abducted by an alien, the first thing I want to ask them before they kill me is, what are y'all based on? Maybe show some sign of intelligence so they won't kill us, right? Maybe you end up in a zoo on some planet, right? I'm good with that rather than still a specimen jar like on the 3rd floor where I have all the animals in zoo, right? That could not defend themselves. But look at this. So the nucleus contains these neutrons that have no charge. Protons have a charge of +1, and electrons have a charge of -1. And so the electrons are held to the nucleus by the opposites attract, the opposites attract, right? The 2 charges, the positive and negative charge. Okay. Now I'm going to take a second here and show you something else, and it's not on the test. But the physicists have discovered that protons and neutrons, electrons are made out of these other like 8 subatomic particles we discovered now. One of them called like neutrinos. Y'all may have heard that one. There's some weird names to these, and they've named them. So y'all have seen on TV what they have these big underground look like motor coasters. They ram these nuclear accelerators and they take atoms and run them together and bust up atoms, and they can take the pieces as they fall apart. Okay. Now we waste a lot. Oh, did I say waste? We spend a lot of research money to do that, and the hope is that some would say waste, some would say not. The idea is maybe we can figure out how to control the reaction that allows the sun to burn for maybe 1 million years or something, right? And then we can harvest that and put it in a little, Elon Musk could put it in your car and have a car never need fuel, right? Or we could find sustainable free fuel. Cheap fuel is the hope. Ain't got there yet. Cold fusion, they try to create that in the laboratory. Of course, they could just blow us all straight to heaven or hell, if they're not careful, right? Because the sun's probably not a good place to live, right? So trying to create a mini sun would be dangerous. But anyway, so you can read that. There are books about that. I'm not going to go there. I just want you to know protons, neutrons, electrons, they're charged, and they each. Now look, we did something else real cool back in the 1800s. These actually have a weight, but we didn't want to get into grams and pounds and ounces, right? We still ain't got that stuff straight, right? Everybody in the world, even the drug dealers are doing what? Selling, gram bags of drugs, right? My drugs I took this morning, prescription drugs were in milligram pills, right? Yet they'll sell milk, in a gallon, and we can buy a pound of hamburger meat. We want a quarter pound of hamburger. You know what I'm saying? So to throw all that out, they just give proton a weight of 1 atomic unit. Neutrons have a 1 atomic unit weight. So we made our new standard because those are the same weight. So we use these subatomic numbers of 1. So when you look at the periodic table, they'll tell you the atomic number and the weight of it, right? And the weight is how much one atom of that weighs. And as you go down the periodic table, they get heavier. Okay. And I'm going to show you that now. So I'm going to there's carbon drawn, and notice it has 4 electrons in the outside shell. Okay. Now notice that. So it has 1. I'm just not going to let me right over here. Let me get the pen here. Okay. So it has 1, 2 in the first shell, and it has 1, 2, 3, 4 in the second shell, and we sometimes draw it like this. And that means it is a carbon that has 4 electrons in the outside shell, so it can bind to what? 1, 2, 3, 4 things. Okay, now where have you seen something like this? Could you say brick? Bricks work really good, right? Because you can grab you got 4 sides to a brick. Okay, there's my dyslexic. You can have there 1, 2, 3, 4. So this is the natural building block of life on Earth. So life as we know it, all living things are based on carbon, have carbon. You're a carbon-based molecule. So is all life on Earth. We found no other life that don't use carbon as a building block yet. Okay, we'll talk more about that in the chapter on 7. That's kind of a big deal, right? It's kind of a big deal. Okay, let me draw a few more of these for you. So here's another one. I'll just go with the table. So here's the cool one. Here's drawn out sodium and chlorine. Okay, so sodium has an atomic number of 11 protons. And now listen, this is kind of cool. At the Big Bang, or when God created the universe, protons and electron numbers equal each other. Okay, so they're neutral. So when God created the universe, there was 11 protons, 11 electrons in sodium. Okay, now here's a rule of physics, chemistry you just might want to know. This equation will tell you how many electrons the shell can hold. Oh, and I'm gonna have to draw it like this. Excuse me. Put the shell number in here, and that'll tell you how many electrons that shell can hold. So 1 squared is what? Wait, I did that wrong. I got the wrong equation. Hold on. How did I do that? Okay. But anyway, the first shell can hold 2. Okay, I think I got my equation wrong. So the first shell can hold 2 electrons. Okay. It's 2. How does that work? 2n squared, I guess. Okay. Yeah, maybe that's it. So 2 times 1 is 2, and then 2. Anyway, I don't know. I'm losing my mind today. So the first shell can hold 2. I can give you that for sure. I know that. First shell can hold 2. The second shell can hold 8 electrons. Okay. So 2 times 2 squared is 4 is 8. Okay, on that. So now look, I don't know why God made it this way. So I cannot argue about this. Okay, there are just some things in physics and chemistry we have to accept. Okay, so this is something you need to get today. The first shell can hold 2 electrons, and the second shell can hold 8. Okay, everybody with me? And the next shell can hold 18. But if it gets to 8, it's happy. Okay, it's be stable. Okay, so in that case, is sodium happy? So it has 11 electrons. Watch, 2 in the first shell. Okay, and now watch this: 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. But that's 10. But it had 1 in the third shell, and that is not happy, right? Because for it to get stable, it's going to have to lose an electron or gain 7. Everybody with me? And one of the keys to chemistry is this: atoms want to be stable. They seek stability, to not have to steal or share electrons to be stable. Okay? And I've got a rule for that just a minute. It is a real rule I'm going to modify a little bit. So what happened when God created the universe? Let's look at chlorine. Chlorine has 17. So it had 2 in the first shell, 8 in the second shell, and 7 in the third shell. Y'all see the problem? Chlorine ain't happy because it needs what? 1 more electron to be happy, okay? To be stable. So guess what happened when God created the universe? All the sodium laying next to chlorine did this. Why don't I give you my 1 electron in the third shell, right? And now I'm happy, right? But I lose an electron, so I'm going to be what? I'll be able to charge a +1, right? And I'm going to give chlorine my electron, and now you're going to have a full outside shell, but you're going to have a charge of what? -1, and those are called ions. An ion is nothing more than an element, an atom that is gained or lost an electron to be stable. Okay? Everybody see that? Everybody see that? I think it's going to show that in the next picture. Let me show you. Oh, come on, man. It's supposed to show that moving. Okay, never mind. I thought it showed it moving. So when God created the universe, all the sodiums laying next to chlorine give up an electron, and we created a -1 chlorine, right? Ion. That's actually an anion, right? Negative, right? And then we made a cation, a positive ion called sodium. And those two are attracted to each other, right? Remember, opposites attract, right? And guess what that makes? It's a compound y'all all know. What's sodium chloride? Salt. That's what I put on my eggs this morning, right? So I have my blood pressure go up. Has anybody ever been out in the woods, maybe deer hunting, and seen a salt lick? It's very natural to find salt in North Mississippi. Big blocks of pieces of salt out in nature, right? Or you can go to co-op buy one and throw it out there. The deer really like that one too, right? That's still maybe illegal, but anyway, it's not if you're on your own land and you want to feed, make sure they have salt, right? Makes their horns big, makes them get really, nice, healthy deer. But isn't that kind of cool? That is not magic, right? That is the way God made the universe, okay? Everybody with me? So first shell can hold 2, second shell can hold 8, the third shell can hold 18, But if it gets to 8, it's happy. The guy, I don't know why God did it that way, but the physicists have proven that that's stability. And the best example I can get of this, I think everybody in here has driven a car at this point, right? Or you rode in a car. Have you ever been in a car where the wheel was out of balance? And then, like, I had a car one time that was so old that when you get 55, the whole thing was shaking. And you had to do 80. It took out, smooth out. That's what I told the highway patrol when he gave me a ticket. I had to do 80 to get out of that shimmy. But sometimes try and go a little faster, and it'll what? It'll level out, right? If you ain't got 80, you're like a tire unbalanced, and you're not stable. You're not happy. Okay? But with me? All right, so write this down. This is something to write down. It's not in the book, but it is called. Now, for those chemistry people, y'all already have this called rule of octave. Y'all heard this? Rule of octave? It's called rule of 8. And here's what it says: is that atoms are unstable, and they want to get 8 electrons in their outside shell. If they can get 8, they're stable. Okay? Now, I decided to change that because most of y'all have not had chemistry. For about half of y'all in here have had chemistry and haven't had it. So I decided to call this, because I've got an ego, so I call it Mr. Robinson's rule of chemistry. So I just stole this, okay? And here's Mr. Robinson's rule of chemistry. All atoms want to do is to be happy, okay? Now, how many of y'all remember, my daughter was a disciple, my oldest daughter, and I think y'all still are, even she's about 8 years older than y'all, but I think y'all know who I'm talking about. My purple dinosaur. Barney. Barney, thank you. How many remember Barney? I love you, you love me. We're so I call it Mr. Robinson's Barney rule of chemistry. All atoms want to do is be happy. Now let's define happy, right, in a subatomic world, and then we got a stupid Barney way to remember it. To be happy, you need 8 electrons in the outside shell. And you can share or you can steal those electrons. Okay? Now I just showed you what? Steal it, right? And that's called a what? Ionic bond. When chlorine and sodium grab each other, when +1 sodium grabs -1 chlorine, that's an ionic bond. And that's what holds the rocks together. That's what holds the metal in this right here together. So ionic bonds is the main one that holds dead things a lot together. I mean, why don't this just fall apart into a million atoms? Ionic bonds hold it together. Okay? Now, sharing electrons, I'm going to show you that one, would involve us sharing an electron, right? So I call that the Barney rule, right? Because he didn't want you to what? Share. He wouldn't want you to steal. I mean, can you see him? No. Steal that cookie. No, share that cookie, right? So sharing electrons can also make them stable. Because they each have 8, for a little while. So they can get that pseudo happy, okay? All right, now let me show you a couple of those real quick. I think that's coming up in just a second. So the atomic number is the number of protons it has in it and the number of electrons at the Big Bang, okay? And usually under that, there will be a weight. Now, they didn't put the weight here on this one. I hate that. And normally I have a periodic table in some other rooms. But under the H will be a number, right? Now, how many of y'all have seen this before on hydrogen? And it should be 1, but it's 1 in a fraction. It's like 1.0738. And what that means is that there's some hydrogen out there in nature that are overweight like Robin. They have extra what? Actually, they have extra protons, not protons, neutrons that make them unstable. And we're going to talk about that in a minute. Those are called isotopes, right? Remember that? We're going to come to that. So let me draw hydrogen real quick. It's real easy. Hydrogen, that's the easiest one. It has 1 proton and 1 electron when God created the universe. Okay? Here it is. Boy, it's easy. It's easy. Look. 1 proton and Shazam, 1 electron in the first shell. That's it. Money. Let's draw another one. That's another hydrogen. What do you think happened when God created the universe? Is hydrogen happy? Nope. What's Robin's Barney rule of chemistry? Got to get a full outside shell, right? To be happy. Hydrogen ain't happy. God created the universe. All the hydrogen laying next to each other. Said, why don't we share that 1 electron you got and a my 1, and we do this, and that's hydrogen gas. That's H2. You can go down there to the running supply at Batesville. I've been down here on the highway I-55 just south of Batesville, and you get a tank of hydrogen, H2. You walk in there and say, I need a tank of H. They're going to step in the back and call the FBI because you're a terrorist and they think you lost your mind. Because you read on the internet how to blow up school, right, with a tank of H. H is very volatile and very dangerous. You can probably set a cylinder right up in here and kill everybody in this room. Because it's unstable gas. I got one word for you, and y'all don't remember this, y'all. This is way, way, way before my time. But y'all remember in history this little thing called the Hindenburg? Okay, good. The Hindenburg is a good example, right? That was before World War II, the Germans had those airships Like the Goodyear blimp and stuff you see for all games and stuff, we fill it up with helium now. Helium won't burn. It's a heavy gas. I'm going to show you that. Helium heavy. Really hard to make, to isolate. You don't make it, you have to isolate it in nature. Hydrogen is really easy to make. So the Germans used hydrogen. And all you needed was a flame and air to blow that thing up real quick. Okay, so that was why that was not very effective anymore. But the Hindenburg was an airship that had a couple hundred people came across the Atlantic, land in New York City, 1920s or something like that, 20s and the 30s. But here's what happened. It's kind of one of those convergences of time and history. So the Hindenburg is landing, and this guy named Kodak just developed film and a motion picture camera to capture live up video. Okay? It didn't have sound, but his people were out there, and they were gonna, it was a big deal. The Hindenburg landing at an airport in New York City, they dropped the rope, and they think somebody dropped a wrench or something in the hydrogen tank, and the whole thing burned in like 8 seconds. And now this is really weird, but the first computer I bought had a world book, like the encyclopedias on a disc, which I thought was really cool, right? Now I've got that on my phone memory, and it had 4 videos on it. Because video takes up a lot of space. It had the Hindenburg burning, it had Martin Luther King's I Have a Dream speech, and it had Kennedy's Let's Go to the Moon speech, and then something else I forgot. And I thought that's the coolest thing ever. Video, wow. I know y'all live with that all the time now. We got YouTube with everything. But that's pretty cool, right? But that is one of the defining moments of the last century. It was the first terrible event ever filmed live. And there were people jumping out like 9/11, popping, killing themselves and on fire as they jumped out of the Hindenburg before it burned up. So like a couple hundred or maybe 100 people died in like 8 seconds. Google that later tonight if you're into horror. It's real, and it's still out there. I mean, it's a real famous. That's really sad. Helium, but safer. Matter of fact, you can breathe it, right? And you sound like Donald Duck. I was telling this joke over lunch one day, and one of the ladies over there that's helping me, my chemistry teacher that's leaving, started tearing up, and I'm like, "Why are you crying?" I'm sorry, I didn't say anything other. I'm just talking about the Hindenburg. I know it's sad, but I mean, it's kind of like old news, right? And she told me she got stepped out of the room, and I knew she was outside father. I said, "What's wrong?" And she said, "My roommate in college killed herself with helium." But she had real depression, and she didn't know it. And she Googled, and she was a brilliant person, but dealing with depression. And she found her for the she bought a tank of helium you can buy at Walmart, and literally put it in a bag and killed herself. She found her in the dorm. So and I say that not to be making fun of that. It just made me sad. So please get some help. I help you. If you need something, we got social workers, we got all kinds of people here. But helium is deadly if you breathe it because it can't. You die of like oxygen. Basically, that person died because they didn't have oxygen. Helium will not bind to you. It cannot bind to anything. It's an inert gas. It's actually right here. Look, it's number 2. So helium has 2 electrons, so it's the first inert gas that won't bind to anything. Very safe, and it's okay to sound like Donald Duck. Just don't breathe it for 8 minutes. You'll die. Very sad. Don't like telling sad stories. That would shoot me up, so I'm careful what I say. So please don't, but I have no idea you could kill yourself with that like that. Okay, the next one is neon. Look at neon. Let's draw it real quick. 10. 2 electrons in the first shell, and look, 8 in the second shell, so it has a full second shell. Bingo, money, right? All you can do with neon is electrocute it, and it glows, and that's called neon light. So that's why neon safe. I mean, it will not bind anything. You break the neon light, that gas is never going to bind anything. I always make a joke. There's nothing you can find at Walmart to eat that's got helium or neon in it. But everything we eat has what? Hydrogen in it because it binds to everything, right? It's always looking to hold on something because it's not happy. I keep trying to drop this home. Some of y'all get it with some of this, you got to let it settle in. Let's do one more. You probably haven't heard of this one. Anybody heard of argon? Okay, it has 8 in the third shell. I'm working at OBS, working in water toxicology on one of my PhDs I didn't finish. And we would check water samples for lead, mercury, and heavy metals. And we had a really expensive, whatever the machine was. It was some kind of big chemical machine to measure it. And we had a big old argon tank. And the argon has a smiley face on it. It won't burn. It's an inert gas. And you would shoot that through to wipe the electrodes off to get all the atoms off of it. So it's used as a cleansing gas. Or, I'm a big fan, I hope y'all don't mind movie references, okay? How many remember Terminator 2, which is one of my favorite movies of all time? When he comes back, he's a good guy. When they blow up the computer building and all that gas comes out, they use argon gas to put fires out in the building. Because argon gas will put the fire out because you can't burn in argon. But if you're in there, what happens to you? You die. You could not put the fire out just like that. But you better get out of that room in like 8 minutes, so you can't breathe it. You can't live on argon. So it's safe unless you're in a room full of argon. And so they, like in space, we can use that as a quick way to, open the hole for the fire out, which you get sucked out too, right? Some of my sci-fi movies, they've done that. But anyway, but argon is a inert gas. And of course, the next one, y'all all know about this one, right? This is what killed Superman, kryptonite. Oh, another show. Okay, never mind. Okay, how do y'all feel about this? So this is very confusing to people who've never seen this before, and I'm sure other teachers have done a much better job than I just did. But that is called the rule of 8. It's called the rule of octane. That all animals want to do is get a full outside shell, but if they can't get full, they'll be what? Happy at 8. Okay? And I don't know why, but that's just physics. That's the physics of it. 8 is a stable situation. 7 is like a tire with that the weight's falling off of, so it's wobbling. Okay? And just imagine those electrons are always moving in those shells. No one's ever seen electrons, okay? They're too small. We have not taken a picture of them yet. We have taken pictures of atoms, but no one's seen an electron yet. But we know that they're just like we know the bullet come out of the gun from what it does to when it hits the tree or whatever. We can predict that from what it does. Okay, now look at the 3 there. Look at that orange. The 4 orange, hydrogen, carbon, nitrogen, and oxygen make up 96% of us. So humans are 96% those 3. So we're not going to do any valence stuff and build out like I did in chemistry, high school chemistry, because we ain't got to get past the 3rd row. All we're dealing with is really what? First 2 rows, right? And then throw in the green ones there on what 3rd, 4th row, and that makes up 4% of you. And the rest of them blues is less than 0.01%. Now here's one of my favorite things to tell y'all. But if you look at the mineral breakdown of me and you, it's almost identical to plants. So when you eat vegetables, you're getting all the elements you need. I mean, it's literally almost the same. The percentages of carbon and all these, right? So eating vegetables is probably a good thing, right? God probably meant us to eat more vegetables. I'm a vegetarian. I'm going to probably die from that, right? Eat too much fat and grease, right? But vegetables and plants have almost the same breakdown as we do. Okay. Any questions on this so far? And I know this is very hard if you hadn't had this before. But I know if you took this last year at Lewisburg or Magnolia Heights, this is a review, which is great for you, right? But for other people, it's been 4 or 5 years since you've seen chemistry, if you ever saw it. And a lot of people not being made to take it in high school, right? So it is something important. Okay. All right, let's go a little bit farther. There's the main thing you may not know. We already said that. Okay, so let's talk about the mass number is protons versus neutrons. Okay, equals the sum of all protons and neutrons. And electrons have a weight. Electrons weigh like 1/1400th of an atomic unit. Because I've had teachers in high school say electrons don't weigh anything. They do. They just not used in math in the atomic weight because you have to have like some hundred to round up to 1. But they have a weight. They're just very low. Okay. Now sometimes you'll see this. Here's hydrogen. There's atomic number 1, and then the atomic weight is 1 on top there. So the number's there. Now look, deuterium is hydrogen that has a weight of 2. So it has 2 neutrons. Okay. Actually, it has 1 neutron and 1 proton for a weight of 2. And tritium has 2 neutrons and 1 proton and 1 electron. So this is something I didn't know that I got into college. Don't feel bad if you don't know this. Isotopes are elements that have extra neutrons in their nucleus, and this makes them unstable. And unstable things do what? Decompose, right? And radiation is the decomposition of an unstable isotope. So tritium is a radioactive isotope that releases radiation that we can measure. And we use that in medicine, for cancer treatments and stuff, right? So it does have a very cool use. We discovered the Calvin Benson cycle and photosynthesis by feeding radioactive carbon to corn and tracing it going through the steps of making sugar. Okay, so radiation is a real serious thing. So radioisotopes are unstable isotopes that give off high energy or radiation. They're 3 alpha, beta, delta, gamma rays. They're giving off 3 different types of radiation that come off. Tritium is one I used to work with in research, and I had to have a little tag, told how much I got exposed to, right? And you can only be exposed to so much radiation, or you can start to have mutations, or it could kill you. Okay, so if we ever have a nuclear war or a nuclear meltdown like Chernobyl, right? That's what happened with Chernobyl in Russia, about 20 years ago, meltdown, and it spewed all this out, and a lot of people around the area died. And a lot of people had cancer because it produced a lot more dangerous. Tritium is not real dangerous. The guys that I have over there today cleaning up our lab. When I became the chairman 7 years ago, 7 years ago, like to the day, that October, I discovered we had a mess up with chemistry. And then we had like 30, 40 years of buildup, and it was all busted balls on the floor and everything. And I didn't know what to do, so I called these guys to come clean it up. And we threw every chemical away and started over at a cost of around $30,000. And when they got through this Friday, cleaning everything up, I'll never forget this. I was the only one here with these two guys. I hadn't seen them in 8 years. They still work for this cleanup company. They came to me and said, "I've got 2 chemicals we can't take." And I went, whoa, y'all the cleanup people. Y'all said y'all can have anything. And they said, "Well, we can tell you what to do with them. We just can't take them." I'm like, what did you find? And they found radioisotope over there called uranium acetate. We had a bottle of radiation over there. For no reason. There's been no radiation experiment ever in the 30 years I've been here. And then there was a bottle of May's pharmacy bottle that had uranium acetate wrote on it. And they wouldn't touch it because they thought it was in it too, but they didn't have a guy count on it. And then we had a chemical that is the date ready. Somebody had ordered a bottle of that you put people out and wake up like 2 days later, you know. And so I had to get the EPA, I had to get the federal narcotics people to come take it and destroy it. And then I had to hire another company to come get that. I think they charged me like $1,000 to come get those 2 little bottles, and they're both hot. They're radioactive. And I asked that guy, "What the heck is that doing here?" He said, "Back in the 60s, every high school had a bottle of that." So when they had all the Cold War, they would get that out and guy counter to teach kids about radiation. And then go put it back in the chemical storage room. So that's probably was residual from the 60s or 70s here that no one ever cleaned up. Isn't that crazy? These are the things we do. But anyway, I just use that. So radiation is a real serious thing. Is anybody in here maybe had family members had radiation treatment to kill cancer? Right? So it kills cells, but our cells usually are stronger than cancer cells, and that's the theory behind radiation, because it's very dangerous. So I didn't know that. So radiation is an unstable atom spewing out that neutron fragments, and those fragments are the radiation it gives off. Now here's a really cool physics thing. We're not asking this on test, but I did have a crazy guy in grad school who did this to us. But y'all know that Einstein has proven that time is not a constant. That the faster you get the speed of light, like those astronauts in space doing 40,000 miles an hour around Earth, they're actually probably gaining like a millionth of a second when they stay up there for 2 years. That time is not a constant. But one of the only constants in nature is radioactive decay. So whatever that rate changes as it turns from tritium to hydrogen, that rate of decay, y'all heard it called half-life, seems to be an absolute constant of nature. And so the greatest, most constant clock on Earth is a nuclear radioactive clock running off of that. It runs off of that. I mean, it runs off of that, detects time. It uses that to make sure that a second is a second. Now, nobody's can buy that, but they got one somewhere in England that is the most efficient clock that doesn't lose time. Anyway, I think you might find that interesting. That time travel was possible before Einstein. Theoretically. Okay, it's theoretical. Okay. That's kind of crazy because he seemed to be one of the smartest people ever. Right? He said his equation seems to indicate that. Okay. All right. Any questions? I'm going to move, but I just thought that's kind of cool to mention, right? Just a little bit of fun on chemistry. Everybody okay with that? And here we are: cancer radiation therapy, radio tracers to discover cancer. Like here's one of my favorite ones. They use iodine-131 to kill thyroid cancer. So basically, thyroid cancer. Here's what happens: you start losing a bunch of weight because you're making too much thyroxine, and it actually makes your metabolism go up. And the treatment is, and I have a nephew that is a pharmacist. That the pharmacist goes in with lead gloves and stuff and pours a glass of radioactive iodine-131. You go in a room by yourself, open a lead box, you take this out, and it says, "Drink all this." Doesn't hurt you at all. They give you a couple of bags. You go home, stay in your bedroom for 2 days, and you collect all your feces and urine and bring it back because it's radioactive. And that kills your thyroid, and it all ends up in your urine. And after about a week, and your poo-poo, and you're good to go. And now you don't have to have surgery. Your thyroid's dead. You just have to take replacement hormone. That's standard treatment. So I had a friend, one of my favorite widows at my church, and I would go around, and we still do go around and take them communion on Sunday. And I got real good friends this lady. She passed away this year, but she was like 95. And so this is not true. She was an old lady, right? But she had a son that had like 3 kids from 3 different women and just trouble. You know, she couldn't get him to do right. And she thought he was 30 and he had enough kids. And so she had this treatment, called him over and told me that she hugged him for like 20 minutes, cried, "I love you, Jimmy. I love you, Jimmy," with her throat right next to his belt line. "Don't leave me, Jimmy. Stay here and just talk to me." He never had another kid. packed. That second part's packed. Now, did she sterilize her son? I don't know. I think that maybe what she did. Okay. But you would not want to sit there. You would not want to have a hot thyroid anywhere near anybody else. You have to say, but she was very, tough lady. She said, I'll take care of my son in his trouble. I'll fix him. Okay, anyway, that's what she told me. If it ain't true, then I still love you. She's gone. Okay, anyway, come on. Now moving on. So we mix things up. Here's a couple of just random terms. Suspension is two or more things mixed together that are unevenly distributed and they will not stay in solution. So blood is like this, right? Blood will settle out over time. Did you know that? So it will settle out. So it's a suspension. Okay, a colloid is where they go in solution and they will not settle out. So milk will not settle out. It's a colloid, but it will go bad, right? So I poured my coffee this morning and I think my milk went bad. Okay, anyway, so I had to got to be some creamer, right? So there's two distinct compounds and particles evenly spread out. And then solution is when one dissolves, right? Where you have water is the universal solvent, which is the main component of us, right? We have a lot of water in us. And then the solute goes in solution. So this is a sweet tea, right? So glucose has a charge on it, right? And it will go in solution. And that's how we make sweet tea. We'll talk about, I'll do sweet tea again in just a second. We're talking about bonds. Okay, and that brings us to bonding. Here is the, I call it Barney bond. This is where we share. It's called covalent bond, where we share electrons. So I drew this earlier, but hydrogen at the beginning of time share electrons and form H2. Okay, now that one is very unstable, right? Dangerous, tank of H. I've used that in the laboratory. All right, now here is oxygen. Oxygen has 2 electrons. So the line between oxygen means 2. Each line means 2 electrons shared. So the second line means how many electrons did it share? 4. So everybody has what? A full shell. Now that is real safe. How many of y'all have ever seen an oxygen tank burn? Anybody? You know, some of y'all have seen. Okay. I don't like doing down stories. That's the second down story. But there was a situation here in Centobe about 15 years ago where this father, his granddaddy was watching the grandkids and he'd been in the hospital and he was on an oxygen tank. And what do they always tell you if you go to the hospital, somebody's on oxygen? Don't smoke around the tank. The dude lit a cigarette and caught it on fire. And my EMT friend said it looked like a blowtorch. And he had like a 13-year-old son there, and he got everybody out of the building, all the other grandkids, which would have been very traumatic, very tragic if the kids had died. And then he went in there with a quilt trying to put daddy out, and he didn't know how to cut the tank off. And by the time the fire department and the police got there, his granddaddy had died in the fire. Don't smoke around oxygen tank, right? But it is relatively more stable than hydrogen, right? But then nitrogen is atomic number. Look at that. Got 7 electrons, 2 in the outside shell, 2 in the first. But look, it has room for what? To share 3 electrons. It has 5 in the outside shell. So it's in triple bond in. So it has 6 electrons being shared. And that is a very stable gas that makes up what? 80% of our atmosphere. I mean, seriously, look at this. Look at this. And this is one of my favorite things. I got to do this real quick. Here is Earth, and here's Fat Robin standing on Earth. Air that you're breathing is about 79% nitrogen gas, which means you can't burn, won't burn, but it's about 21% oxygen. Guys, this is one of my favorite points. Air we're breathing is about 20% oxygen, and that makes a great mix where you can light a fire and not ignite the atmosphere. You can burn a log in the backyard, right, and not set the world on fire. You tweak that, you make that, 60-40, and you light a cigarette at break, and you just burn the whole world. It's like fireball Earth. Okay, jack that up to about 90-10, and we're still in the cave, booga booga, popping rocks, and they can't get spark, can't get fire, no wood, no engine. Okay, and I did this the other day, y'all with me, but this woman girl looked at me like, and I said, no cars, no electricity, and she's still like, I give it that, I don't give a crap look, like, I said, no cell phone, and she's like, oh my God, this is important. She jumped up when I said no cell phone, okay? You understand, we'd still be in the cave, right? No development, no evolution of mankind. So thank you, Lord, for what? 80-20, and I don't think that was random. That was universal master design, right? Please don't think that's random, because you tweak that a little bit, and things go really weird, crazy, right? Get crazy real quick. Isn't that cool? A safe gas, a gas we can use, right, to release energy in our food, right, to let fire. When you burn wood, you're oxidizing it. You're releasing the carbon and electrons in the wood. Anyway, I'm trying to show you some interesting reasons to know that. So sharing is covalent bonding. And here is a cool one here. There's a rule of octave. So there is carbon dioxide, right? C, but you see that where you have 2 oxygens with 8 electrons, so they can share with carbon. So carbon loves to be happy now. Okay. So we got that rule to either 2 or 8 to be stable. That talks about that. And now ionic is when we steal electrons. We already saw that one, right? So a cation is anything that has lost an electron and is now positively charged, and these are a lot of metals. And ions will receive electrons, and they are negatively charged. And here's that sodium and chlorine. There's a picture I was looking for earlier. So look, at the beginning of time, sodium had 1 electron outside shell. Chlorine had 7. So sodium give up the chlorine, became a what? A positive. It lost an electron, so it is now +1, and then chlorine is -1, and that is an ionic bond, and that's table salt. Now, how many of y'all, if you got little kids, little cousin, little brother, here's one of my favorite little tricks. Water is actually like this. It's H2O and has a bend in it. Okay? Let me show you this. We're going to talk about this in just a minute. There is a bond called hydrogen bond here. We're going to talk about this second. So water is held together with hydrogen bonds. If you drop salt in it, sodium becomes what? Plus ion. Oops, sorry, let me do that. And it binds to this, and chlorine will bind to this, and it goes in solution. Have you ever seen that? Drop salt in a big glass of clear water, in a beaker of water, and it's magic. The kids, you just drop salt in and it disappears, right? Gotta impress the kids, right? Then take it to the oven, boil all the water off, and what's left in the bottom of the beaker? Salt. Okay, is that cool? And so when you put table sugar, which is a what? Disaccharide into the tea, what happens? It's 2 rings and they go right to the bottom, they don't go in solution, right? But when you put it in hot tea, it breaks it apart into 2 ions of glucose that have a charge, and that's why sweet tea is made, because it goes in solution. I'm just trying to give y'all something you can go home and think about, right? So sweet tea, you put the sugar in when it's hot, the heat breaks the sugar, the disaccharides into monosaccharides, and they go into solution. They have a charge. But if you pour cold sugar and cold tea, you're going to what? Stir the hell freezers over, right? Or you make a slurry. Who's done this before? Who really had to have sweet tea? You drank it while you stir, and to give you the illusion of sweet tea. That's when you're really addicted, like I am to Diet Coke right now. Come down to Church Christ on Wednesday night. We have the drug addictions. We have the drug addiction meeting every night of the week there. Come on by, I'll see you. We'll hook you up on our Narcotics Anonymous. Our brother-in-law just got his 20-year pen a couple of weeks ago at that over in Tupelo. So I went over to his. That was an interesting meeting. Never been to one of those. That's pretty entertaining. Here's some of the stories. But anyway, he's gone 20 years clean. So that's really good. Really good. Anyway, cool. That's ionic is what? Sharing. It's the stealing of electrons, right? So that's that. Oh, test question. 3 types of bonds, right? Sharing electrons are what? Covalent. Stealing is ionic. And the third one I just did a while ago, I'm doing it again, is the hydrogen bond. Okay? Let's do that. Let's look at that one. So the hydrogen bond, here we go. Look, wow, I should check the head. I didn't get a chance to preview. There's my oxygen. There's my nitrogen. There's a methane group. If it's 1 electron, it's single bond. If it's 2, it's double bond. If it's 3 pairs, it's triple bond, right? And we represent that by the lines between the atom and letter. Okay? And opposites attract. Now, let's look at this. Then we're going to get to that third one here. So some compounds are shared electrons equally, like this. Nitrogen, the electrons are equally shared. Everybody got that? Because each side has what? Had 7 protons or whatever, right? Now, same thing here in carbon dioxide. It is pretty even. It's strong like that. But sometimes you get something weird like water. Look, there's sharing. So water is going to be an unequal sharing. Watch this. So we get a polar compound. Water does that. Let me show you why. Oxygen has how many protons? It has 8. Hydrogen has 1 proton, and this hydrogen has 1 proton. So if 8 of y'all get on one end of a rope, and me and my gentleman get on the other end, even though we're 2 manly men, he's more manly than me, you girls are gonna get the rope. I cannot win. I don't think even 2 of us guys can hold against 8 of you girls, right? So who's gonna get the electron more? Here, the electron's gonna be over here more, right? On this side. And that's going to make this thing kink, so you have a 108-degree angle between these 2. Okay? Now, I hate to say this. How many of y'all heard this before? Like, I always get mad when somebody says, oh, Billy was having trouble. Y'all, he did He turned his life around. He did a 360. He's still doing drugs. We did 360, 360 the circle, y'all. So if you're doing something stupid, you do a 180. 180 is the other way. Just a little bit of knowledge here. Okay, so the angle here on between the oxygen is 108 degrees. In carbon dioxide, it's a straight. It's a straight on each side. And this creates a situation so that this side is slightly negative, not a -1 charge. If it was, it would be what? Ionic, right? Everybody with me? And this out here, over here, is slightly what? Hot. That's what that represents. And this sets up our third type of bond, called the hydrogen bond. It's a weak attraction between hydrogen in a polar covalent bond, everybody with me? And another element also in a polar covalent bond, usually oxygen. So water looks like this. Look, here's water. That's a table of water. That's a glass of water. I brought a glass of water. I am thirsty, but it's also my prop today. Those hydrogen bonds hold that water together. Now watch this. This is about the best illustration I got. I pour a little water right here. Look at it. It's grabbing each other and staying together. That's hydrogen bonding. And it's fixing to roll off the table because that chair is on it. Now, that's why boats float. That's why I can float. Because I float really well. I'm very buoyant. You little thin ladies, y'all might sink to the bottom. Okay, we can hold your breath and float a little bit. Okay. But boats float and all because hydrogen bonds keep us up. I boil that, I break the hydrogen bonds, and once it does, it makes the steam, right, and the hydrogen, and then you can breathe better, right? Get that moisture in the air, right? Isn't that pretty cool? That to me is one of the coolest things. Thank you, Lord, for hydrogen bonds. So hydrogen bonds is a weak attraction between hydrogen and a polar covalent bond and another atom, usually oxygen, but it can be nitrogen and other things, and that's what holds water together. It's also very important. It holds our DNA together. That's spiraling staircase of DNA. Now look, I read this somewhere in the book. I'm going to paraphrase it because I'm getting old. But somewhere I read this years ago that if we did not have hydrogen bonds, water would boil at -400 degrees Fahrenheit and freeze at -600. There'd be no water, we wouldn't be here. We'd all be done gone. We'd done all vaporized, all vapored off. So hydrogen bonds is one of the coolest things in nature. Now, I hope, no, we got plenty of time for this, right? Because I've cut a bunch of tabs out, so I have more time to talk. And I think this lets it settle in on y'all. So y'all forgive me if y'all like the story. But I think I got one y'all like on this already. Okay, everybody, now for some of y'all, it's like last year. So for Bailey, it's it's 2 months ago. So everybody think back to high school. Now for some of you, it's a long time. I got to go way back to the 80s, okay? But how many of y'all remember in high school, that girl or guy that everybody wanted to date? I mean, one of my best friends, this guy, and we were still friends, and he was sleeping with 2 girls, the 2 best looking girls in school, and they fought over him in the parking lot while he was trying to date their other best friend. He was a sorry player, right? But he just had an attraction, right? Women were attracted to him. I have a girlfriend that everybody dated, and she was not super beautiful. She wasn't super, whatever. She wasn't being very promiscuous. She was not doing anything wrong. She just had that person. I had it. There's something out there. Remember, I think there's an it that we can't quantitate. Now, we'll talk about it later in the endocrine chapter. Maybe it's pheromones. Maybe we get off pheromones that say, I'm smoking hot. Or I'm not really that attractive. Okay, okay, but here's what I was in high school. How many of y'all, and I'm sure one of y'all can relate to me. How many of y'all, nobody wanted to go out with you, but you was everybody's best friend? That was me. You and I were hydrogen bonds in high school, right? Weak attraction, right? That really good looking girl wanted me to help her with homework, and I took her to the movie and stuff. At the time I tried to kiss her, she went like, I don't think we're not like that. We're not like that. So I was hydrogen bond in high school. Friends with everybody, but couldn't buy a date. I'm not mad about it, I just said it is what it is. I'll tell this before this little phone here, but we'll talk about pheromones and Miss Nickens will. But I walked in on the first day of class where I don't think I knew anybody in here. I knew one girl before me and her. I helped her out before advising. But I'll walk in the room and I'll just pick on you because I know you're cool. We talk, we text at 5:30 in the morning, okay? But I will come in this room and I'll just go like, and yesterday I'll be like, I want her. Now, I have no reason to think that, right? I wonder if some chemical didn't tell me something, right? And then I'll think, she's a saint, right? Maybe as sweet as can be. And so I end up lecturing to her the whole first lecture to make sure she feels good about class. I don't want her not to be loved because I want her to treat her equally, and I'm going to treat everybody the same. And kind of find out she's super nice, and she's the one that picks me up on the side of the road when I have car trouble, and Bailey's out there keying my car. Later, the camera saw Bailey, go to hell Robin on the side of my car with her key, right? And so when I was 17, 18, I thought I could judge people, like I could have some guilt. And I found out that I'm 50-50 on guessing people, which means I have no guilt. I wonder if pheromones don't do that to us, where you, like, I can go up to a dog and all dogs like me. I'm going to have one dog bark at me for 50 years. Okay? But I mean, I think dogs can tell what the character of people sometimes. You ever have somebody that this dog hates? If I was a boarding class school, I didn't wonder. They have better nose than we do. I tell you this, it really happened one time. So I had this girl that was like me and you, that was like the remember weak attraction? I was a hydro in high school. And she come out one day, she said, man, nobody asked me out. And I'm like, dude, I ain't going there. I talked to you about my auntie, I ain't gonna be your social counselor. I said, but I said, well, I talked to her friend. And she said, you hear this radio station where they talk about you could buy these a cologne or perfume that had pheromones in it? So she said, this is like 30 years ago. She saved up like $150 and bought this bottle of perfume. Or cologne perfume for girls. And it's supposed to be the male attractant. And I'm like, okay, scientific experiment, right? And we talk about scientific methods, and give it a shot. She came back to my office after 2 weeks and she was in tears. And she said, no boy has asked me out. I've had 2 girls ask me out at Walmart, and my best friend confessed that she's loved me since the 6th grade. And I said, burn the damn thing. No, that, by the way, they may sent you the wrong one. Not that there's anything wrong with that. That's just what she wanted. I've been like, yeah, hey, you got, where's my wife leaving? Where's that girl one at? I need to give me that number. Give me that phone number. I'm just saying, like those fives, and the girls jump on you. That doesn't work. Tried that. Didn't work. Anyway, just a little fun. But isn't that cool? That helps me remember that. So it's a weak attraction, right? You know that guy. Come on, girls. You know that guy you like to school and he was your friend, but you just want to go out with him. Okay. That's your hydrogen bond. Okay. And of course, no wait. Now I got another one here, right? So what was this one? Oh yeah, man. What about that? What about that ionic bond, right? Oh, that ionic bond was dating, man, because opposites attract. Y'all know what I'm talking about, right? Now when you get 18, 19, you girls realize probably not a good idea to date the guy that's selling crack. You're gonna clean up and change, right? You're gonna clean him up, So then you find somebody more suitable to you, right? Okay. And same with boys. Boys like the bad girls, right? So opposite attract, that's teenage dating, right? Anyway, 3 types of bonds. I'll shut up. Ionic, opposites attract, kind of how dating is, somewhat, and then what? Hydrogen bond is sharing, the weak attraction, and then the covalent bond is sharing electrons, right? Okay. Now look, I've been running for about 50 minutes. Somebody asked a question here, and I want to tell you something. Y'all have asked more questions yesterday than I think I got all last year. Last year was like a coma. We had 50 minutes for once a week, and I mean for like this we've done 50 minutes for 2 chapters. I'm telling you, it was crazy. So I got to run the race. Okay. So anyway, anybody, what's bugging y'all with this? Anybody got a question about this? Yes, ma'am. Fire away.
So covalent, hydrogen, ionic. What's the 4th one?
That's just it. Just 3. Yeah. I think I named some of them twice. Remember I called the covalent, the bonding bond just sharing, and then ionic would be stealing. It'd be like I don't know, somebody steal stuff. Okay, like the rubber bond, right? They steal that electron, but it's all about getting what? Aid in that outside shell. So when you look at it, in a minute we're gonna look at like things like sugar. Everybody's happy in sugar. That's why they stay on the shelf for 5, 10, 20 years, right? Because it's not going to decompose. It's happy. Okay, it will eventually decompose, but all right. Go ahead. Look, seriously. Look, we're going on. It really, I appreciate that. Thank you so much. Because if you say something really bothering you, this is a good thing. I'm not going to be ugly. And even if I'm trying to make a point, I'll come back to you. Just keep that hand up and I'll say, I got you. I'll come back to you. Because that's important for y'all to be able to ask that. And that's the thing I think we miss with online classes, right? You can watch this video, but you still couldn't ask that question. You had to email me to be like 2 days before I got back to you. You know what I'm saying? But that's a good question. Okay, and this some random stuff like on the midterm, we can see something like we can see isotope that's turned on. Remember, that's an atom that has extra neutrons in it that makes it unstable. And that kind of makes sense, right? If you pack too much clothes in the suitcase, what happens? It blows up eventually, right? And that's what radiation is. So not all isotopes are radioactive, but the ones that are very important medically. And for my radiology lady, she's going to be dealing with that. When she's going to be using X-rays big time and helping people use that to diagnose cancer and all kind of problems, right? And then treatments. Now they have the laser focused, those proton atom guns that can shoot the electrons in there to kill cancer. So really cool stuff. Okay, and that's what water looks like. That's a glass of water. Okay, and that's why the blood there bubbles up, like I poured the water on the table. Okay, and then they're going to go back over the rules and just shows you how there's a molecular drawing for sugar, I believe, or something there, that just shows how everybody has the number of electron shares they can have. That rule of octave must always be enforced, right? Okay, then we can have different types of reactions, right? Okay, so chemical reactions are when we mix chemicals together, the things we put together into a reaction are called reactants. The things that come out are products, right? You can have reversible reactions like this. Carbon dioxide plus water makes carbonic acid, and that can go either way, so that's reversible. Okay, then you can have, does that say reversible? Irreversible, I'm sorry. Reversible is when they go back, but you can't burn a piece of paper and bring it back. That would be irreversible, right? But so some reactions, though, are reversible, okay? And then we got just a little bit of energy here. Remember, energy is defined as capacity to do work. And so I used to ask students, what's work then? And people were like, go silent. The use of energy to do something, that's actually a reverse statement there. But basically, what we're going to see is that we need energy, ATP. We have to make ATP in the cell to do everything that requires work. So everything, movement, thinking, even thinking about how stupid this class is today, you use ATP to do that. And this is where we should have the energy chapter I told you about that's over in AP2, right? So energy is used, there's different types. Sugar, a candy bar, a gallon of gas is potential energy, right? That's stored energy in the power. There's power in the bonds, in the electrons. There's power in the bonds of these food molecules. Kinetic energy is stepping in front of a car. Energy in motion, right? You know, some falling on you. Okay, that is energy. That is not potential. That's not stored. That is actual, real released energy. So here is a rock on top of a hill that represents what potential energy you get from that boulder. You experience kinetic energy, right? So a bullet blowing a hole in a tree is kinetic energy being expressed. Okay? Just throw that in here, a little bit of energy on that. Some reactions release energy, right? Like photosynthesis, you know, makes cellular respiration releases energy. Photosynthesis stores energy in the sugar molecule. So what we do is we eat sugar, release the energy from that, or we eat the cow meat who ate the sugar from the grass, and we get the energy in those molecules of proteins and fats and sugar. Chemical energy in the bonds. Electricity is electrical energy that we harvest and run through these copper wires, right? And mechanical energy, it would be a car, you know, the energy produced as a car moving as you burn the gas. My 28-year-old daughter her and her husband bought their first car yesterday. Their first car. I had bought her a car and give it to her. My dad gave me a car. I tried to do the same thing that my dad did. And I bought her like a little Prius when she was like, you know, like maybe junior in college, and she kept it. They still have it, but they bought a hybrid RAV4, and those are really pretty one. Yeah, but I say that because that has what the hybrid makes it more energy efficient, right? Theoretically, okay. Still have to replace those batteries every 10 years, right? But we'll talk about that later on about energy efficiency, right? And so that mechanical transfer of energy from gasoline into turning and transmission is mechanical energy. Okay, reactions that require energy are endogernic. So photosynthesis is endogernic because it takes sunlight and makes sugar. Exogernic is when you burn a piece of wood or burn energy. When we do cell respiration in our cells, we literally release the energy in the sugar molecule and make ATP out of that. Now, I would love to cover that right now. I think it should be right now, but we'll wait and cover that. The chapter 3 goes to the cell, but it would be energy in a lot of other books. Okay. So reactions now this is the thing y'all heard about. Some reactions break things down. Catabolic reactions, right? Means the word catastrophe, right? Means to break down. Anabolic means to build up. Because if you take anabolic steroids for weightlifting and eat lots of protein, you can get as big as the wrestlers, right? And all the WWE wrestlers are all shooting steroids. That's not natural. Very few people look naturally like that, okay? So that requires a lot of weightlifting and use of anabolic steroids usually, okay? And some good genetics too. Helps to have good genes too. And some reactions just exchange things. And that's just showing you some of that. Nothing big here. Exchange reaction there. Here's two terms that drive people crazy. You may hear this a lot. You're going to see this in the book. But some types of reactions are said to be oxidative reduction reactions. And this is a special kind of exchange reaction where electrons and energy exchange instead of atoms. And really, cellular respiration is an oxidative reduction reaction. So as we burn sugar, and I'll draw it here for you. I'll just give you this because I think y'all are really paying attention and make this help. But the key to life on Earth is this. Take a look. C6H12O6, that's sugar, plus oxygen, which is needed, can make 6 carbon dioxides, 6 waters, and 36 to 38 ATPs. Okay? Now guys, look, I'm gonna tell you something, one of my favorite biology facts in the world. Every living organism we have ever found in the universe to this day uses ATP as their energy source. The odds of that randomly happening are zillion to 1. And would you like to know why they all use ATP? Because we all, life on Earth, come from one source. I think God did it. I don't know how he did it. Maybe he'll tell us one day in heaven. But we're all kids of that first protozoan, whatever, zooplankton, whatever, that started life on Earth billions of years ago. Okay? All right? And that is proof of that, right? That we all use one energy. I mean, that's crazy. That'd be like everybody on Earth using American dollars only. No other currency. That would be like every cell phone using the USB port charger. And y'all been to Walmart, right? There's a whole row of what, 82 different chargers for every brand of phone. Now we're down to just 2 phones, right? But Apple's got their special one, right? Just imagine one charger. Or one type of battery. Everything on Earth we're on AA battery. This is that. There's your AA battery. ATP. Okay? Is that cool? So we got to have energy to do everything. Now watch this. That's us. Plants take that carbon dioxide, water, and sunlight, and they build sugar that we all eat. And they make oxygen that we need to break sugar down. So something you may not know is plants have the mitochondria to build sugar, to break sugar down, but they have the chloroplasts to build sugar. So they can make the cake and eat it. We can only eat the cake. So we got to eat them or eat somebody that eats them. That's what we do. Isn't that pretty cool? So that's a big thing we'll talk about later about how that energy is important. As this carbon dioxide is oxidized, that is an oxidation reaction. And when we build sugar, that's a reduction reaction because the sugar gains electrons. And the power is in these electrons that we exchange. So when you take the chapter in AP2, we talk about cellular respiration, it's called oxidative reduction because we oxidize the sugar and reduce carbon dioxide, and we reduce carbon dioxide, we make carbon dioxide. Plants then reduce carbon dioxide to build sugar. So photosynthesis is just the opposite of aerobic respiration. That's cool. So we do mitochondria, equation down with our mitochondria, plants have mitochondria. They just make more sugar than they need, and they use that for structural material. And then we like to cut them and cut them at the ankle and eat them, right? Or feed them to a cow and eat cow. Pretty cool to me. Anyway, just something, but that's the term you need to know that pops up. When you burn firewood, you're what? Oxidizing. That's an oxidation reaction. A fire, imagine your fire pit is oxidation reaction. Okay, antibiotic, build things up, right? And most reactions require what's called an energy of activation. So almost every reaction needs a certain amount of energy for it to work. And we'll talk about enzymes. They lower the energy of activation. So enzymes are a weird thing here. They mention them here. Enzymes are usually proteins. There are a few RNA ones, but they lower the energy of activation needed for a reaction to occur. So, for example, for A and B to make C, you need this much energy. Enzymes lower the amount of energy needed, so you need less energy to do reactions. Okay? And enzymes are very important in our body. But they're proteins, so when you get a temperature, you know why we worry when your temperature gets below 105, you start denaturing the enzymes in your brain and you lose things like who you are and how to breathe and all kind of really important functions. But other than that, temperature is not real dangerous. It just starts to cause, and the best example is the commercial fried an egg. You got that snot looking stuff that turns into plastic, right? And it never goes back. That's denaturing an enzyme or protein. Okay? So enzymes are metabolic molecules that we have to have in our body that lower the amount of energy needed for reactions to occur. And that brings me to a very important, another one here, I believe, is sometimes some reactions, that's showing how enzymes work. They can grab A and B and make C, make a product. So enzymes grab the reactants, make them come together, and make a product. Now, let me throw one out here that y'all might find interesting. There are another company, I think it's in this slide, if it's not, let me go ahead and tell you. Their enzymes need ions, little organic molecules sometimes called coenzymes, or they need an element, like hydrogen or iron or something, an ion. But it's gonna blow your mind. Guess what the more common name for these cofactors are that y'all all heard of this. You see this on the TV every day. It's called vitamins. Vitamins are organic molecules that you can't make that enzymes have to have in order to work properly. So if you don't have the right vitamins in your diet, it's like me going out there and taking your 6-cylinder engine and taking 3 spark plugs out and you drive to Memphis. Well, you'll make it maybe. It'll sound awful, right? You ever had a spark plug go bad? It'll mess up and it sounds awful. You'll think it's going to blow up. So these are God's spark plugs. Vitamins are things we have to do cell respiration that serve as coenzymes for these enzymes that we make. It's kind of a cool thing. You'll see that later. Okay. I don't think they mentioned it here. Here are some enzyme issues. Taussat disease is an enzyme deficiency. This severe combined immunosuppressed syndrome where the kid lived in a bubble, the bubble kid, the kid that came, any germ will kill them, is an enzyme not working right in their body. And PKU, here's one that's got a lot of press play in it. PKU, phenylketonuria, is a problem because if you eat too much phenylalanine, that's one of the amino acids, and that's also one of the amino acids needed to make NutraSweet. So people who have this disease cannot take NutraSweet. That Diet Coke up in the drink has NutraSweet in it. It has a warning label on it that it has NutraSweet in it. And if you have phenylketonuria, your brain will not develop normally if you're a child, and it could cause problems later. However, there's no scientific proof that that would hurt you on its own. People talk about it turns into phenylhalide. Dude, you don't even want to know what reactions going on in your body. Everything's capable of everything. Okay? But my take on things, anything, too much of anything is bad for you, right? If you're drinking 22 Diet Coke a day, that's probably not good for you. It's going to kill you with high blood pressure. Too much sodium in it. Eating too many gummy bears will probably kill you if you eat too many of them. You know what I mean? Or too many Twinkies. Make you look like me, right? But phenylalanine, but that's the one that's created NutraSweet. There's a lot of websites saying NutraSweet's dangerous because of it, but you cannot eat NutraSweet if you have ketonuria. That would be really bad. All right, this is a great place to take a quick break because we're going to go into inorganics and organics. Let's take a 5-minute break. Want y'all run the bathroom real quick. And look, I do break a rule in here. Look, let me break a rule in here for y'all. I'm not going to. But y'all can bring a drink in here like y'all did. I don't mind if y'all bring coffee or water. But if you spill it, you clean it up. That's the rule. Okay? And no water or drinks allowed. If I come in with a Diet Coke, my world is blowing up. Y'all just leave me alone. Okay, let's just do loud. just play nice. Okay, Robin's having a really bad day. Okay? That's my go-to release, right? Instead of alcohol or something. Okay, I drink with Diet Coke. But anyway, but y'all, I don't know if y'all get a Coke or something. There is a Coke machine or a Pepsi machine over in another building. I'm over on the 3rd floor, I think 2nd, 3rd floor on that end. They have some. But let's take 5 minutes and y'all can go to the bathroom, especially ladies. Charge up your phone. How much we're going over? Let's take 5 minutes. We'll do a little bit of this. Go ahead, let's take 5 minutes. And I'll be 30 minutes more. I think I can finish this in 30 minutes. Really just look at this stuff. The rest of this pretty. Huh? That is all right. Oh, just standing up. I hear you. I know. Y'all need to get up, move around a little bit. Appreciate y'all. That makes sense. That make a little bit of sense today with this song. Okay, I'm gonna pause this. They don't need a recording our. Find somewhere up here I can pause. Oh boy. I think I stopped the video there. We can start again. Read over that chapter if you hadn't had this mic. Don't know. I'm not going to turn this into a big chemistry test, but I may have you, somebody ask some questions about the bonds, right, stuff like that. We're not going to draw any like big. I'm not going to give you 2 random atoms, and we're not going to do pairing up anything like that. I believe that's the chemistry.
I was wondering, like, what exactly do we take that from? What I'm saying?
Oh yeah, I mean, just got whatever you think's important, but you got time to just go through it. But I don't really like people trying to write everything I say. I think that's a waste of time. But I might print out the PowerPoint and then make notes on top of those so they get through the little part. You can print them up at home or bring a laptop, where you can or you've got the book, make notes in the book or something. You can bring chapter 3 to class, chapter 2, and write down things there's obviously a test question there about the types of bonds, about how bonds work, what does it mean? What about the rule of 8? How atoms bind each other. But just stuff like that. So you just got to get the concepts down. Yes, I don't give. I don't give you 20 terms though. I mean, you got to know everything. So I'll just go randomly pick it. But I'll give you the short answer questions. It should be in there. Just now. You have a question?
I've been making notes from my homework.
Not bad. And then the online homework stuff is good. If you see something in there, the midterm is going to have test bank questions. Some of them are like that in the mastering homework. So those are good, Yeah, I mean, I'm just gonna, but I think, I will limit myself to the short answers that I have posted on that sheet. I think one of them is picked off the bonds, probably should be on there if it's not. And we got a big one coming up in this last 30 minutes, is list the 4 big organic groups and know what they're made out of and what they do for us. It's pretty standard. I mean, I'll probably do it in 30 minutes. I didn't realize I just late. I took a little longer than I wanted to, but then I may come back tomorrow when we start 3 to see it again real quick. It's just real easy now. But the problem is, make sure you get there's 2, don't list inorganics. Make sure you understand there's an organic, inorganic. That's what we've been talking about. Because organic are those with carbon in them. Okay, that's sugar, proteins, fats, and nucleic acids. And inorganic are things like water and carbon dioxide that we have to have, but then we don't get energy from them. You know, the water is the most famous inorganic, right? I mean, it doesn't have the word organic means to have carbon. But we eat the organics to stay alive, but our main component is primarily water. Water is the universal solvent. Yeah, I wish they charge too much for that stuff too.
They made it, but it just got caught.
Okay, well, they'll probably come by and bring it to me, because they were 2 classes, and they'll probably come by and talk to us. Okay, now this last part of the chapter is kind of looking at these 2 types of we're gonna build some compounds, okay? And so there's 2 things we gotta throw out here real quick about inorganic and organic, okay? Now, the word organic means to be made out of carbon and hydrogen, but the key is carbon. So all the molecules on planet Earth that are made out of carbon are said to be organic. They have lots of carbon and hydrogen in them, okay? Now, that also usually implies it came from living. Okay, so you may see a guy on TV like, I have a nursery in South Haven, it's all organic grown. Well, everything grown on Earth is organic. What he says is he made it without any herbicides and pesticides. So that word is kind of used wrong sometimes in media, but organic means you're made out of carbon and hydrogen. And there are 4 big, now look, let's do this, because every year I do this test. and I'm using a different test this time, but one of my cancer, if you took me last summer, this has been on the test, right? What is an organic and what's inorganic? List the 4 organics. I think that's one of your short answer questions, I do believe. Okay, so the 4 organics are this: sugars, proteins, fats, nucleic acids. So you and I are made, all animals are made out of what? All living things are made out of sugars, proteins, fats, and nucleic acids. And those are all carbon, hydrogen-based molecules. We're going to look at them real quick, but I got to do inorganics first. Inorganics are things that are what? Not made out of what? Carbon and hydrogen, right? I've got to turn my video back on. We started back. So, organic are things not made out of carbon and hydrogen, right? And organic are things made out of carbon, hydrogen, and we will see a big table that lists them. So the big 4 organics are sugar, proteins, fats, and nucleic acids. And we're going to get to them in this great table at the end of the chapter, okay? Now, let's look at inorganics first, though. So inorganics, biochemistry, or here's the word that is said. Organic contain carbon and hydrogen, hydrocarbons, see all these? We draw carbon rings, those are rings of sugar. Where you see a line, the corner is a carbon, okay? So we're made out of organics. Inorganics are things that do not contain carbon bound to hydrogen, but are water and things like acids, base, and salt, all the salts. All those are inorganic, okay? I'm sorry, I thought everybody back, sorry. We good? So these are inorganic. Okay, water is the most famous inorganic. It makes up 6 to 8% of your body. It is the main solvent in our body. It prevents our body from getting too hot or too cold too quick because water is slow to heat and slow to cool. Y'all know that, right? We've got a swimming pool. Anybody know swim yet? Swimming pool? But it's pretty cold right now, right? Because it still hasn't warmed up, right? But then you can swim on into October around here, right? Because it takes a long time for that water to cool off. And so God was really smart at making living things out of water, right? So that it's slow to change temperature. It will evaporate at 212 degrees. Can y'all imagine now? Think about this. You take this for granted, but who saw that coming? Nobody saw that coming, right? You put water on the oven and start boiling it, and then we start heating it, and when it gets to 212, all hell breaks loose, right? It starts bubbling and it becomes gas. Okay, so that's always the kind of things about that's the physical nature of water, right? But water will eventually boil and evaporate off, but it's a super lubricant, super important. Yeah, it's the main solvent, universal solvent, right? And hydrogen bonding, remember, it has a partially negative end and a partially positive end that creates the hydrogen bond and waters your water again. So go back and talk about water again. Okay? So water is the super solvent. Okay? Now, things that don't mix in water, like oils, are said to be hydrophobic. I mean, they hate water. So oils don't have a charge in them. So that's why oil and water dressing, you got to shake it up to get a solution to pour it on your salad, right? So oils, like methane in this case is a gas, is a non-polar compound that will not mix with water. Because water wants things that have a charge. So oils and fats are said to be hydrophobic, right? They hate water. Okay, now we're gonna do this real quick. I'm gonna do this real quick because this is one of my favorite things that really confused me when I was y'all's age, when I was starting out in my science class. What is pH and what is an acid base? Okay, so anybody, quick thought. What is an acid?
Are we talking about like?
Just about how would you define acid? There's no bad answers, it's just bad teaching.
Less than 7.35 on the pH.
Less than 7 on the pH scale. That's absolutely good. I would take that. That would be full credit. Yeah, less than 7 on pH scale. Anything above 7 is a base. Everything below 7 is an acid. Okay. Now, chemically, an acid is something that releases hydrogen in a solution. Okay. And a base is anything that grabs it up. Now, look, I struggle with this, y'all. Fix the stop. If y'all don't get anything else, you're gonna love this part of my class. Because I hate things I can't explain. So I took a guy in grad school on water chemistry, and I got this. Because here's what got me. And I think it's in the PowerPoint, but let's just double check. So pH, here's the equation. It's the negative log of the hydrogen ion concentration in grams per liter. So if you tell me how many grams per liter hydrogen in a water solution is, put that in the calculator, hit the log number, and you get the pH. Okay? Now, go with me. Now, stay with me. Now, pure water has all them hydrogen ions in there, right? Doing that, we saw this a second ago. Some of these break apart into OH and H. but really, pH is a measure of what? Hydrogen ions, right? You might get, well, I'm more used to this. Watch this. You put that number in the calculator and hit log, you get 7. Pure water has 0.01 grams per liter of hydrogen ions. So water usually holds itself together, but that much hydrogen per liter exists in pure undistilled water. So pH is really a measure of what? The hydrogen ion concentration, and 7 is neutral water. Because see, when I first saw this in college, I'm like, or high school, all right, that's stupid. Why does the scale go from 0 to 14, 7 neutral? I figured some British scientist was smoking heroin at a heroin den in the 1800s and just made this number up, right? It would have made more sense to me to go from 1 to 10 and have 5 neutral, right? So it's not what I want, it's not what those scientists wanted, it is what God made it. Pure water has 10 to the minus 7.0 grams per liter of this. Now watch, this is where it makes sense. That's 7. That's pH neutral. Okay, watch. You're gonna love this. You can go and try to calculate later. That's pH 6, 5, 4, 3, 2, 1. Right there. pH 1, I had an extra 0. It's 0.1 gram. Pure acid. You get it? Go the other way, 14 zeros is oven cleaner, hydrogen peroxide. Okay? So the pH scale is not some bunch of dudes smoking heroin. There it was. There's the equation. Stomach acid, stream acids have lots of hydrogen ions, right? Very little OH. And then when you get to a base, it's all OH, like bleach. Now, guess what? One of the most dangerous. Does anybody know? I should do that. I'm gonna freak somebody out. Anybody get little kids? Does anybody get a little kid? Okay, nobody's asking. Okay, does anybody got like little brother or something? Little 2, 3-year-old brother? Okay, be careful with this one, okay? The most dangerous thing at your house is oven cleaner on the sink. Take that out to the carport and put it up high. Because if you eat a can of borax, it'll dissolve your digestive system. You'll die in just a little while. Okay? Really, it's dangerous. And I saw a video one guy, this guy back in the 80s, he was trying to kill himself, and he ate a bottle of borax. But right when he ate it, he just had this epiphany, I don't want to die, which is a good thing. Dial 911. When the ambulance EMT got there, he had dissolved his esophagus and his stomach and like a top third of his small intestine. But they were able to pull it out and put it out, get to neutralize it. They pulled his gut out, put it under his skin, and reconnected it to his throat. And it messed up his vocal cords too. But then he became an activist trying to help people. And so he goes to school, pulls his shirt off, and eats in front of kids, and watches his food go to his stomach, and he runs to the bathroom because he has to go to the bathroom nonstop now. And of course, he says, don't do drugs. So he makes a living doing that today. Okay. Saw him do that. You can see the food go down. So really dangerous because it dissolves you. Okay. Same thing on the other one, stick your finger in a battery. Don't do that. Okay. You'll melt your finger off, right? So acids are very dangerous. But we seem to overlook bases. Okay. Coca-Cola, Coca-Cola is like pH 4.5. One of my favorites, it's acid. If you're driving somewhere this weekend and bugs get stuck on the windshield, you turn your windshield wiper on, it just makes a mess, and you squeeze your juice is empty, pour a Diet Coke with Coca-Cola on the windshield. You'll thank me later. It melts the bugs off, you turn the windshield wiper on, you get a little sugar sheen, you're good for 2 or 3 days. It'll burn it off. I used to do an experiment with summer camps. I take Diet Coke, I use Sprite because it's clear, and I put goldfish in pure Sprite. They die in 3 seconds. Put them in 50% Sprite, and they die in about 2 or 3 minutes. Put them in 25. I diluted it 50% all the way down, and they can live in like 1% Sprite. So when you pour that Coke out the window, you just killed all the darn bugs. He's killed all the little midgets and little worms out there. They melted. Kind of like, who did the salt on the, you know what I'm talking about? You put salt on slugs. You wouldn't do that, so you're too nice. Okay, but there are guys that probably done that. Probably a couple girls in here. Pour salt on a slug and just melt them away. pH is super important, okay? And so this is important because we have to be right around this or we're dead. If our blood gets above, 7.45 or something like 7.56, you're dead. Below 7.35, you're dead. So pH is very important, but here are some common things out there in their pH. But it is, and this is my favorite point today. Guess what? Okay, now look, y'all are fried fruit, okay? I'm gonna give you one guess. What does H stand for in pH? Money! All right, I love y'all. All right, here we go. Helium! Okay. Long summer, okay. Guess what the little P stands for? You ever notice it's italics in the book? It means persons, which translates into English to power of. So it's the power of hydrogen. Okay, pretty cool, right? So power of hydrogen. I mean, it's Greek, Latin, or whatever. So it means percent power of hydrogen. So pH is all about hydrogen ions, okay? That's pretty cool. All right, so anyway, enough on that. Buffers then are things that what? Prevent changes in pH, right? And so the most famous one, there is our blood, 735, 745. But here is, and I almost marked it on the board. I'm gonna ruin this $5,000 TV. Okay, well, look at this. This is bicarbonate. Okay, if your pH gets too high, it can grab that and become H2CO3, thereby what? Raises your pH. But if your pH gets too high, it can release hydrogen and make your pH go down into HCO3. So a buffer is anything that can grab a hydrogen or release a hydrogen to keep the pH what? Steady. That's the main carbon, that's the main buffer in your blood. It's also the way we carry carbon dioxide in our blood. We'll see later on in AP2. So bicarbonate is God's main buffer, and it's how we carry carbon dioxide in our blood, because water don't like gases, and I don't have time for that today, but we'll talk about that later. Water does not like gases, is another theme of mine. Okay, so enough on pH, and then every time you go from 3 to 4, it's a factor of 10, right? So it's 10, it's 10 base. The log function makes it base 10. Okay, and now we go to organics. Okay, now here are the big four: sugars, lipids, proteins, and nucleic acids, right? What are we made out of? Sugars, lipids, proteins, and nucleic acids. What do we eat? Well, we eat all four, but we don't get energy from this, but we get energy from these, right? So we can't, I'm sure we get a little energy, but nobody's eating nucleic acids for energy. We use them to make our own DNA and stuff. And I hate to say it, but y'all heard this in kindergarten. You are what you eat? Bam. It is true. So you eat proteins and fats and use that to build your body. So weightlifters eat lots of protein, right, to build muscle mass, right? And you can control your body. I've lost 100 pounds twice. Then start 3. I'm gonna go to the gym one day and I'll have about a 400-day straight run, okay? But the last time I did that was about 8 years ago, and I hiked 24 miles one day, up to Half Dome and back down. Pretty crazy. Carbohydrates include, and now here's where it gets weird. They are usually ring structures, right? And monosaccharide is a single ring like this. Ribose and deoxyribose is a single ring structure. Here's glucose, here's fructose, and here's lactose. So here, these are real famous single ring sugars, right? Real Dr. Pepper and stuff, the old ones were made with glucose, right? And fructose, and that's pure sugar. You drink that and you get a sugar high, whoa, it goes right through your bloodstream, right? Get quick. Good stuff. Those old Dr. Peppers from the old factories where they make them with pure fructose. Table sugar is sucrose. And see, it's a diuretic, it's a disaccharide. It's 2 rings stuck together. So heat and Mama's sweet tea breaks it down into fructose and glucose that then become charged and go in solution. So sucrose, disaccharide is glucose and a fructose stuck together. Okay, isn't that kind of cool? Everybody get the sweet tea thing? So hot water makes it break apart. Okay, and then polysaccharides include glycogen. Look at that. So long carbon chains, and this is how we store sugar in your liver. That's what bread looks like. Bread is long glycogen carbon chains of glycogen. Now, how many of y'all know another one, real famous one, and they don't show it here, but cellulose is a different pattern. And God did not give us enzymes to break down cellulose, right? And so if you're on a diet, if I start my diet tomorrow, what does every diet in the universe say? There's one thing in common in all diets. Eat all the lettuce you want. Not salad dressing, not crouton, not bacon. You put me in this room with a case of water and a case of lettuce, and I will lose weight, and I'll be dead in about 8 months. I got about 6 months of food. And one of you real thin, beautiful ladies, you last about maybe 2 months, right? I'm just saying, I carry fat as stored energy, right? But you can lose weight on a diet by eating cellulose, because that will come out the other end. That's roughage, right? You're gonna have bowel movement when you eat lettuce, okay? Because you can't break it down. That's actually glycogen, but it's actually a different shape. And cows have to regurgitate and eat it twice, right? Have to have the 2 stomachs and all that. And then the termites actually have a protozoan in their body that has a bacterium in their gut that breaks down the cellulose for them. I don't know if y'all knew that. One of my favorite experiments, we used to bring termites in and gut them under a microscope, and you can see the protozoan swimming in there. You just gut them, and you can see the little protozoan, but there's a bacterium in the protozoan that breaks down cellulose. That's how they eat wood. Yeah, we can't eat wood. Okay. And also another one here that's falling here. How many of y'all have ever had shellfish, like shrimp and crawfish? I love shrimp and crawfish. Don't eat the shell. That's chitin. And it's another sugar, different structure, and we can't break it down either. So you eat shell, you eat a pile of crawfish tail of shrimp shells, you're going to be dropping some shells out later tomorrow, okay? Out the other end, okay? Because you can't digest it. Kind of cool. Okay, fats are energy storage, and they are made out of long carbon chains called fatty acids. And if it has a kink in it, it is unsaturated. If it's saturated, it has all hydrogen. So saturated, all hydrogens, double bonds are unsaturated. Okay, and there are omega fats in fish and oil and some seed oil. That's a good fat, but we like to eat animal fat, which is saturated fat, which is lard at Walmart that we cook French fries and chicken in, and that is what's killing us. Probably the number one killer in America because this clogs our arteries. So saturated fats are really bad for you. You want to eat unsaturated. And then man-made one called trans fat is even worse than saturated fat. And now they're banned in restaurants in New York City. So here's a man-made fat that we put in some of our foods for a health store or whatever, called trans fats. Significantly increase heart attacks. They've been outlawed in some foods. The most common fat in your body is triglycerides, and that is three fatty acids and a 3-carbon sugar called glycerol. And here's what it looks like. This is the one around my stomach. This is in my liver. Triglycerides is stored fat. Now, here's one for y'all. Listen to this. We'll talk about this in AP2. A gram of sugar and a gram of protein have half the energy of a gram of fat. Fat has 2 times more energy in it than sugar and protein. So if we're on Gilligan's Island, there's nothing to eat but 100 pounds of Garibaldi sugar chocolates, and there's 100 pounds of ribeye, prime ribeye from Como Steakhouse already cooked, or 100 pounds of fat butt lard, pig lard. Take the lard. You'll live twice as long. You got twice the calories, and we'll cook these little girls later if they starve to death. We'll have a little Bailey kebabs later, okay? I have no desire to eat one of y'all. We're on desert island, and you don't eat what we feed you, Boston bud, filet mignon, wings, chicken, finger wings. Look at everything now, but it's just protein, right? I'm sorry. But that kind of cool. So fats have a lot of energy. So if you want to go on a diet, what should you avoid? Eating fat. And that's what most diets try to get you to lower your fat intake because it's so powerful energy. Hey, no joke. I got it somewhere more powerful ones. Does anybody have the McGriddle from McDonald's? Probably the most deadly thing ever created. Okay, we got your sausage and some bacon and some greasy eggs, and we got a pancake shaped like a biscuit with syrup injected into it. It's like 800 calories. And it is like, I had one time on a road trip, and I had to get another one because I wasn't even thinking about being full. So one day on one of the morning shows, they had that McGriddle out there, 800 calories, or they had like 2 pounds of grapes. Same calories. Like a pound of grapes, or 8 ounce, or 1/10 of an ounce of the McGriddle. So the fruit and vegetables, which are very expensive to buy at Walmart, right? Fill your stomach better and better for you. But I still like to go to McDonald's every once in a while, right? I'll probably go to that now. Let's say that. Okay, but anyway, so triglycerides and energy. Here, your cell membrane is made out of phospholipid, which is another type of fat with 2 fatty acids and a phosphate group that makes it charged. So this side has a charge and it likes water, and this hates water. So our cell membranes look like this. So it's two of these. So this is what your cell membranes look like. I've been known to make people draw this. Your cell membranes are 2 phospholipids with the fatty acids scrapping each other. The guy, one of the most embarrassing moments of my teaching career one time, as I said this, and I talk real fast, and my English is not real good. They will let me do the videos. I told you yesterday. But I was doing this, and I'm going to close my eyes. I'm not looking at anybody, but I was saying one more time, the fats are made out of what? 3-carbon sugar called glycerol, and I turned around and I said, and 3 fatty acids, and I looked at this little girl with this palm. Just randomly. You're very not strong. Okay, so but not too thin. Okay, don't be freaking out. You look fine. I looked at this girl and she goes, "Did you just call me a fatty acid?" I said, "Play the tape back." I said, "Fatty acid." Fatty acid. Okay. No, I'm not gonna call, I'm a fatty ass, I'm not gonna call anybody else one, okay? But I do have a lot of fatty acids around my stomach, okay? And oh, by the way, guess what the book tells you? It's easier to put it into this than to get it out. Oh, I didn't need to buy an $80 book to know that, right? It's hard to lose weight, right? It's hard to break it out, break it down, okay? So anyway, God could have been nicer there on that. Thank you, God. All right. And then steroids are another group of fats that are 4 ring structures like this. Most common one is cholesterol, which is only found in animal cell membrane. So if you're a vegetarian, guess what you don't have? You have no cholesterol in your diet, and you will probably not die of cardiovascular disease. Because cholesterol is what causes the coronary arteries. That's the number one cause of death in America, and the big time number one death in Mississippi. So cholesterol is used to make testosterone, and estrogen looks just like this, just change a few of those functional groups. So the sex hormones are 2 types of steroids, and I think because of anabolic steroids, if you go and say steroids, everybody thinks what? Either Arnold Schwarzenegger shooting up, or or Caitlyn Jennings taking it to be some guy or girl taking estrogen, right, or whatever. You know what I'm saying? But here's the deal. Only the anabolic sex steroids are the ones that would change your body or whatever, right? Cholesterol is a normal, very important compound in your body, right? That's used to make other things, but we eat too much of it, and it causes our I have a brother, the lawyer in Texas. His daughter broke out some rash. She got some chicken, some poison ivy. I get poison ivy, and my poison ivy just eats calamine. They like calamine. It grows on calamine. They eat it. It's just our genetics in our family. And so I told him, I said, you got to take her to a doctor. And he did. And this is my brother who never took biology class. He said, but he prescribed some steroids, and I don't want to turn her into a boy. And I went, you biology idiot. They're giving you hydrocortisone, which is which is a steroid that has nothing to do with sex. It just stops your immune system from attacking. Poison ivy and poison oak is your immune system over responding to the allergy. The hydrocortisone, EpiPen or whatever will then knock your immune system down, so you stop swelling up when you have an anaphylactic shock. So it's an overreaction, and we'll talk about it in APT. He really should have taken a biology class. So I had to call his brother-in-law and say, just go take the girl with a shot. Because he was scared, he was going to turn into a little boy or whatever, that. And I'm like, dude, the system, it's a media problem with steroids. I said the word steroid, it takes testosterone and estrogen, but really cortisol is a very important hormone, has nothing to do with sex, and this relieves inflammation, right? If you ever had a bad ankle or shoulder, cortisone shot, not going to make you turn into a boy or whatever, okay, whatever, not the one they use for sex change or whatever. Okay, proteins can fold up into different structures, but here's the main point, is the sequence of amino acids make the protein, okay? So there are 20 different amino acids, right? And the sequence of them make the protein. Let me explain to you like that. Like I'm Robin and you Tom, T-O-M, R-O-B-I-N, that don't mean nothing. But in protein, R-O-B-I-N makes Robin, okay? And R-O-B-B-I-E, my wife, would make Robbie. My wife is named Robbie. So the actual sequence of the amino acids makes the protein. So the only difference between Alpo and Como Steakhouse Prime Rib is the sequence of amino acids in the right order. Okay? Now, guys, look, I missed the whole cell phone thing, right? When I came here 30 years ago, I invested in payphones because I saw students calling parents and using all the payphones. Kind of missed that whole cell phone thing. A lot of money to be made, right? Okay, Mr. Microwave. Didn't think everybody needed one of those. Okay, I've been predicting this for about 30 years. Here's the next big thing in the next 10 years. You're going to go get a protein generator. All it needs is 20 tubes, right? The 20 amino acids, and you can make, some Corky's barbecue, just put the chicken, the right combination. You got chicken wings, or you got pork butt, or you got prime rib. All proteins, egg white, it's all just different spellings of these amino acids. You ever, like pig thigh is different than chicken thigh, right? It's just the way it's spelled. So primary is the order of the amino acids, and then how it folds. The secondary and tertiary is multiple proteins stuck together. Quaternary is 4 or 5 big proteins stuck together. It's all about the structure. And when you cook your egg white, you denature it, and it changes the structure, secondary, tertiary, and quaternary structure, and they never go back. But the base thing once you get on proteins is the sequence of amino acids. Look, every amino acid has a carbon in the middle, an amine group, a carboxylic group, a hydrogen, and this is what's different on each of them. Look, and the sequence of those, glycine, serine, cysteine, makes every protein. You will have a protein generator one day. I'm a Star Trek fan, sci-fi. I love Star Trek, right? They had the food generator. You watch Star Trek, they go over and go like, I'll have a Salisbury steak and a cup of coffee, and they pull it out, you know. I don't think we're a long way, but we're not far away from the protein generator. Now, I say that, has anybody seen a 3D printer? That's pretty scary. So we got the first one in Northwest, and they said, Robin, bring something from biology to big meetings. I brought a limit skull I had. He laid it on there, he used some scanner, and 8 hours later, I had a carbonite exact replica. I think the first one was like a golf shaft, you know, that was that, you know, the shaft of a golf club. What is it, carbon or whatever, carbon base, and then but he could do 3 different things. There's a doctor working on printing kidneys right now. And instead of ink, it shoots out stem cells. And he is printing ears and body parts, but the big one is kidneys we're trying to do because people die of kidney failure all the time. And guess what he did? He was at the beach and a seashell washed up. And what's a seashell? It's what's left is like the cytoskeleton of a shell, of a living organism. And that's when he had the moment. He started going to cadavers and taking kidneys out, digesting all the organic matter out, except for the cytoskeleton. And he's printing on that. And he's real close to doing that. So he's using the cytoskeleton as the matrix to print a freaking kidney. So I'm excited about that. So I'm waiting on my protein generator. Okay. And just showing some neat stuff. There's it showing it folded. And then the last one is nucleic acids are made out of nucleotides. Nucleotides have a sugar, a nitrogen base, adenine, thymine, cysteine, guanine, okay, and a phosphate group. And these include, there they are, there's the 5 nucleotides that make up nucleic acids. And this is information storage. This is our genetic material that we pass to our children, right? This is genetic information, and ATP is a modified one of these. So ATP is a modified nucleic acid for energy. But these are the 5 things in DNA. But remember, uracil replaces thymine in RNA. And it looks like this. RNA, there's ATP, which is a modified nucleotide to release energy. And then DNA, every 3 letters in DNA code for an amino acid. And this is one of the most important things I can tell you today. Look at that. DNA, which is your genes, a sequence of this tells us how to make proteins. And proteins do all things in living organisms, do all things. Okay? Now, let's pick on Robin because I don't want to hurt anybody's feelings. But I got DNA that says I'm going to be short, and it made me short. I got DNA that says I talk too much. It made me a decent teacher, at least entertaining somewhat, right? Okay? I talk too quite fast. I got personality traits from my mother and her daddy ran a grocery store. He was a salesman. I just been peddling biology for 30 years, right? Personality, IQ, everything that's genetics is achieved by DNA telling us how to make proteins. Proteins are enzymes and they do everything. So the fact that the DNA makes me have something wrong with an organ or whatever. Is that cool? Now here's the one that's going to blow your mind. It's about the end of the note here today. About 40 years ago, we discovered what the letters coded for. Y'all heard of genetic code? There's a genetic code we're going to talk about in chapter 3 that tells you that like AAA codes for one of the 20 amino acids. Well, right after they did that, they then discovered they did the genetic code for rats, dogs, and E. coli. And here's my big thought for the day. You are all kin to all life on Earth because not only do we all use the same energy, we use the same secret code in the DNA. So there's one universal code on planet Earth. So the spelling of 1,000 nucleotides makes, you know, robin hair, and the cat hair just spelled a little bit different, makes cat hair. Okay, but the coding is the same. Now there are a few weird bacteria that have a few spelling differences, but we think those are bacteria we'll probably find on Mars, you know, something like that. Some very weird ones that can live in boiling water or acid, okay, called thermoacidophils, okay, and the methanogens that make methane. But for most purposes, 99.99% of all life on Earth has the exact same genetic code. So theoretically, I could, and I told this one time in class, so I'll end our lecture on this. I can eliminate 2 terrible things in America on Earth with one genetic experiment. We can put chloroplasts in everybody and eliminate starvation. All you have to do is go outside, put your swimsuit on, drink water, and you get fat as Robin. You make your own sugar. And then I will eliminate racism because we'll all be green. And of course, everybody at Chicago Board of Trade for corn and commodities will jump off the building and kill themselves today because I just destroyed the commodity market, right? Because nobody's going to buy grain to feed cows now because we can all make our own sugar, right? So that would disrupt the markets, right? Quite a bit. And on the way out, I love this. One of my favorite students that year came out, and I told that joke about him for 20 years. And he came out and he said, Robin, that's awesome. But I bet within 2 weeks, the dark greens or the light greens would be fighting the dark greens because they take the better each time. I said, that's part of human nature too. I think it is to not, anything that's not like me, we find we're scared of. You know what I'm saying? I still think that it would be the dark, you see that the dark greens find the light greens, right? Anyway, but isn't that kind of cool? But DNA, guys, is universal on planet Earth. And that's one of the reasons why I think God put that first living thing down here. And we're all, I think God descended us from that. Okay. But that's the only story I got on that, because we don't know how it would happen. We'll have to wait for somebody to tell. Okay, so what are the four organics? Sugar, ring structure, right? Proteins, fats, and nucleic acid. Which is the one we don't get energy from, really? DNA, nucleic acid, although it's used to make ATP, we don't store that as energy or anything. So you like to eat sugars, proteins, and fats. Okay, and look, there's RNA, DNA, talks about that. There's more DNA, lots of DNA, and there's RNA single strand with uracil in the place of thymine. We'll talk about why God made RNA later this week. And look, nice table at the end. Look at that. All the organic compounds. Look, nice summary table. I always make this joke. If you wake up right before the test on a 12-day hangover, read the table. The review table is excellent at the end of the chapter, right? All right. I got 30 seconds left. Anybody got a question? Did I do a little better today? I think that's a little bit better lecture than yesterday. Chapter 1's kind of filler anyway, right? All right. 100% probably. Anybody got the short answer questions? Is that not one of them right there? List the 4 organic compounds. It's on the midterm. You might as well memorize it. And look, let's do something that has not happened in a while. We can do it. Do not list 4 inorganic things. Do not put down water and oxygen and carbon dioxide and miss 5 points on the midterm, right? Those are inorganics, right? Organics are what? Things made out of carbon and hydrogen. We just saw, right? Sugar, proteins, fat. Look, one of my favorite girls when she ended up making a B or C, wrote on this test question. She put down concrete, asbestos, and what's the black stuff out there? Tar road, and then like and vinyl siding for her 4 organics. And I just went like typed it, put it on my office wall. That is embarrassing. She was -0. We got 0. All right, any questions? All right, so today in lab, we're going to look at the cell cycle. We're going to look at chapter 3, and we will go into chapter 3 here tomorrow. Okay, I'll see y'all at 1:30. The cafeteria is open if y'all want some quick food over there for $5. I don't know what I'm going to do for lunch. I'll leave a number right over there. Y'all welcome to go over there and go get you some food. Y'all got an hour. Look at that. Man, look at that. 12:30. I'm right on the spot, ain't I? We're supposed to go 12:30 now. What's up? Yeah, 12:30 is what I had. Yeah, 12:30.